Awesome. So this is our second video on stationary points. I thought that I'd do another example separately from the one that I did before, just to make it more clear to those who maybe would have loved to see more examples. All right. So it's just basically going to be a problem-solving video. Nothing. Not much. Not so much to explain here. All right. So we are supposed to identify the stationary points on the curve y equals to 1 plus 4x cubed minus x raised to minus x raised to 4. All right. So after we've identified the stationary points, we are also then supposed to find the nature of each of the stationary points, all right, as the second part of our question. So we already know that stationary points basically have a gradient of 0. So we are going to find the first derivative of our function y and then equate it to 0. All right. So it's going to be the derivative of y with respect to x, okay? And of course, we have 1, which is a constant. And remember that the derivative of a constant is always going to be equal to 0. There's a reason why. X in this particular case is assumed to be raised to 0. And so when you multiply the index of x, which is 0, times 1, you always get 0. All right, and then plus, okay, 4x cubed. So the derivative of 4x cubed will be 3 times 4, and that will give us 12, all right, x. And of course, that's the index 3 minus 1. The index 3 minus 1 giving us 2. Minus 4 times negative 1, which is the coefficient there, will give us negative, all right, negative 4. All right, and x, so 4 minus 1 will be x cubed. All right, that's okay. So this is our first derivative, and for us to find the stationary points, we are supposed to equate it to 0. Awesome. So I want to look at the function we are having here. Of course, the equation we are having here, which is equated to 0. And note that there is a common factor. All right, so we have 4, can multiply both 12 and negative 4 there. All right, and we are having x and x here. So we're going to pick the one with the lowest index. So to factorize this, we basically going to have 4x squared into, all right, so 12x squared divided by 4x squared will basically give us, all right, 3. Will basically give us 3. So that's going to be 12 divided by 4 giving us 3, and x squared divided by x squared giving us 1. So basically that is 3 times 1, which is just 3. All right, minus, okay, so in here we are having negative 4x cubed, and we are supposed to divide it by 4x squared. So that's going to be 4 divided by negative 4, which will give us negative 1. All right, so x cubed divided by x squared will give us, that is 3 minus 2, giving us x. All right, giving us x raised to 1. So basically this will be 3 minus x, okay, 3 minus x. Why? The coefficient of negative x is just negative 1. So that's going to be 3 minus x, okay, 3 minus x, all right? And so this all will be equal to 0. Awesome. So for us to find the values of x here, we're basically going to divide both ends by 4 first of all, to get rid of the coefficient that is 4 we're having here. And so that's going to leave us with x squared into 3 minus x equals to 0. So if you've been following our classes, then you realize that for us to have that this equation here is actually equal to 0, it means that either the factorized form, the factorized term is the one that is equal to 0, or whatever we have in the bracket is the one that is equal to 0. All right, so basically for x1, we'll find x1 by equating we'll find x1 by equating x squared to 0. All right, and so when we equate x squared to 0, remember the square root of x squared will actually be, all right, will actually be 0. All right, so basically it's x squared equal to 0 And so when we find its square root, then we notice that the square root of course of x here we'll have the square root being x, and of course the square root of 0 will be equal to 0. So we cannot have plus or minus 0. We cannot have 0 that is positive and negative. 0 is just 0. Okay, so the value of x1 here will actually be 0. All right, so for x2 we are going to have 3 minus x being equal to 0, and so notice that our value of x here will be equal to 3. All right, when you do your math, the value for x there will be equal to 3. All right, so if any one of you have a question around that, drop a comment in the section in the comment box, and I'll help you out maybe to figure that out. That is just simple quadratic equation simple algebraic expressions and equation stuff. All right, that should be easy by now. All right, so this class is basically centered around that. That's why we are not really going to give much attention to it, as this is a differentiation class. Okay, so we have our value of x1 and x2. All right, so our x1 is actually equal to 0 and our x2 is actually equal to 3. Then can we go ahead and find the values for y? All right, and find the stationary points. Okay, so we are going to find the value of y1, and for us to find the value of y1, we are going to use the value of x1, which is actually now equal to 0. All right, so y1 will be equal to 1, okay, plus 4 into 0 cubed minus 0 raised to 4. And so notice here that our y1 will be any number multiplied by 0. Our y1 will be equal to 1. So the first stationary point in this particular case will be 0 and 1. All right, will be 0 and 1 as our first stationary point. As our first stationary point. That is for the value x equal to 0. Okay, so that's going to be our first stationary point, that is 0, 1. Right, so for us to find the second stationary point, we're going to basically substitute the value of x2 into our function y there. So our x2 value is actually equal to 3, so that's going to be y2 being equal to 1, okay, plus 4 into 3 cubed, all right, minus 3 raised to 4. So the value of y2 here will actually be equal to let me do the math there, 28. The value of y2 here will actually be equal to 28. So that therefore means that our second stationary point will actually be x2, that is 3, and 28, which is the value of y2 there. So we are having our stationary points. We have stationary point 1 and stationary point 2. Okay, stationary point 1 is 0, 1. Stationary point 2 is 3 and 28. So we've actually identified the stationary points on the curve y equals to 1 plus 4x cubed minus x raised to 4. And for the second part of our question, we are supposed to determine the nature of each of these stationary points. So we're supposed to determine the nature of the stationary point at 0, 1, and the nature of the stationary point at 3, 28. All right, so let us do that and see what we get. Awesome. So to find the nature of our stationary points, remember we are going to take the second derivatives of our function y. All right, and we mentioned key points that when the second derivative is a positive number, it's a minimum. If it's a minimum turning point. If it's a negative number, then it is a maximum turning point. However, when it is equal to 0, we said that it is a point of inflection. So that is what we are basically going to do here. All right, so the first derivative of our function y here, dy with respect to x, will be, of course, the derivative of 1 there is 0, all right, plus Okay, so that's 0 plus 3 times 4 giving us 12x raised to 2, as in 3 minus 1 there. Beautiful. And so that's going to be 4 times negative 1 there, giving us negative 4. X raised to 4 minus 1, that is going to be 3. All right. So that is the first derivative, but we are looking for the second derivative. Okay, so that's going to be the second derivative of our function y with respect to x will give us 2 times 12, which will be 24. X raised to what? X raised to 1, as in 2 minus 1 there. All right, minus 3 times negative 4, which is going to give us negative 12. X raised to 3 minus 1 giving us 2. All right, so we are having our second derivative as 24x minus 12 x squared. All right, so what we then do to determine the nature of the stationary point, we actually take the values of x at each stationary point and substitute it into this particular expression function. Okay, so then we note that our first stationary point was 0, 1. Okay, that was our first stationary point. It was 0, 1. Okay, that means that our x value is actually equal to 0. So for us to find whether this second derivative is greater than 0, or that is, it's a positive, a negative, or equal to 0, we are going to substitute the value of x directly into the equations. All right, so notice here that we are going to have 24 into 0 minus 12 into 0 squared, and all this will give us 0. So basically our second derivative, okay, of our value of our function y is actually giving us a value that is equal to 0. And what do we know about that? We said that when the second derivative is actually equal to 0, then we have that is a point of inflection. All right, that is a point of inflection, a point of inflection. Okay, so at 0, 1, we have a point of inflection. Okay, why don't we determine the second stationary point and see the nature of its turning point? Was it a maximum, minimum, or also a point of inflection? All right, so our second stationary point was 3 and 28. 3 and 28. And so for us to find the value of the second derivative, we'll substitute directly the value of 3 into our second derivative here. So that's going to be 24 into 3 minus 12 into 3 what? Into 3 squared. And notice that this will give us, negative 36. This will give us negative 36, which is a negative number. And so we said that when the second derivative gives us a negative number, then it is actually a maximum point. So at this particular point, we say that the coordinate 328 is a maximum turning point, is a maximum turning point, is a maximum turning point. So that will be it for today's tutorial. If any one of you have any question, feel free to post it in the comment section, and I'll get back to you as soon as possible. Thank you and have a lovely day.